This is very, very interesting. It's from Be Inspired. Very interesting.
That's truly intriguing. This theory delves into the realm of cymatics, a field that studies how sound vibrations can shape and form patterns in physical substances. In beehives, bees are often heard buzzing, a sound produced by their wings flapping at high frequencies. This buzzing is not just a byproduct of their flight, it might play a crucial role in constructing their honeycombs.
Bees are very cool this way. So a hive of bees will thrum its wings in the key of C. And when you put somebody with PTSD, post-traumatic stress disorder, in the presence of a beehive, that C retunes their cognitive dissonance of post-traumatic stress, and over the course of a few months, that PTSD can go away simply by being in the resonant frequency of the key of C from bees.
Honeycombs are famous for their perfectly shaped hexagons, a geometric marvel that maximizes space and efficiency. The theory suggests that the sound vibrations from bees buzzing could be influencing the wax, guiding it into these optimal shapes. The foundation of this theory lies in cymatics, a term coined by Hans Jenny in the 1960s, although the phenomenon has been observed for centuries.
Everything owes its existence solely and completely to sound. Sound is the factor which holds it together. Sound is the basis of form and shape.
Cymatics involves the study of how sound frequencies can generate possible patterns in different mediums like liquids, powders, and fine particles. When a surface holding these substances is exposed to specific sound frequencies, the vibrations cause the materials to move and form patterns that correspond to the sound wave characteristics. This phenomenon is often demonstrated using a Chladni plate, a flat surface covered in sand or salt. When this plate is vibrated at certain frequencies, the particles align themselves into patterns that reflect the waveforms of the sound. Each frequency produces a unique pattern ranging from simple lines and circles to complex and intricate designs. These patterns are not random. They directly correlate with the sound frequency and waveform. Lower frequencies tend to create simpler patterns, while higher frequencies result in more complex designs. This relationship between sound and physical form is key to understanding how bees might use sound in their hive construction. The hypothesis that bees use sound vibrations to shape their honeycombs suggests that the frequency of their buzzing could be fine-tuned to optimize the wax construction into hexagons. The hexagonal structure is the most efficient for storage and strength, which is critical for the hive's survival. Bees, through millions of years of evolution, might have developed the ability to use sound as a tool, not just for communication, but for engineering their environment. This idea opens up new avenues in understanding animal behavior and the complex ways in which different species interact with their environment. It also highlights the potential of natural sound vibrations in shaping physical structures, a concept that could have applications in various scientific and engineering fields. Anthony Holland's innovative approach to combating cancer involves using resonant frequencies to target and destroy cancer cells. His research, conducted at Skidmore College, focuses on finding specific frequencies that can disrupt the structure of cancer cells, causing them to shatter, much like a glass breaks when exposed to a high-pitched sound.
We now know that cancer is vulnerable between the frequencies of 100,000 hertz and 300,000 hertz. So now we attack leukemia cells. Leukemia cell number 1 tries to grow a copy of itself, but the new cell is shattered into dozens of fragments and scattered across the slide. Leukemia cell number 2 then hyperinflates and also dies. Leukemia cell number 3 then tries to make another cancer cell. The new cell is shattered and the original cell dies.
This method shows promise as a potential alternative to traditional cancer treatments like chemotherapy and radiation, which often harm healthy cells alongside cancerous ones. Holland's experiments involved exposing different types of cancer cells, including those from leukemia, pancreatic, and ovarian cancers, to various frequencies and observing the effects. He discovered that certain frequencies led to the disintegration of the cancer cells.